Hi guys, so in this short video we are going to see the protection system overview, how the protection in EHV takes place. Okay, so we'll start with it. So this is the bus, 220 kV bus where all the lines and transformers are connected, and this is the bus PT, and then this is the line, or it may be a transformer. Okay, so first thing here it is bus isolator, then there is a breaker. All right, after the breaker there is a line isolator, and then there's this CT. Okay, the CT has 5 cores. First one is used for main protection, then second one is for backup protection, third is for metering that we have not shown here, then one is for LBB, and then the last one is for the bus bar protection. Okay, so breaker has two tripping coils, trip 1 and trip 2. For redundancy, we have used two tripping coils because protection is very important, and a negative is continuously being given to the tripping coil, both tripping coils, and the positive is being extended from the 86 master trip relay. Here master trip relay we have shown. Okay, all right, so we'll start with first relay, that is the distance, main protection distance or differential. Okay, so the CT, this is the secondary of the CT. The secondary of the CT is being extended to the current coil of the relay, and the same way PT is extended to the PT coil of the relay, and positive is continuously given to the output contact of the relay, of the distance relay. Okay, so when the relay detects the fault, it continuously monitors the current and voltage, and when it detects a fault, when the impedance goes beyond the setting, then the relay operates, and this positive is being extended to the 86 relay. The negative is continuously given to the one end of the operating coil of the 86 relay, that's the master trip relay, and when it receives a positive from the other end, the 86 relay operates, and the positive is continuously given to its output contacts, that is then extended to the tripping coil of the breaker. Okay, and then the breaker trips. Okay, similarly, when the distance relay fails, for that we use a backup relay. Here we have shown an overcurrent relay. Similarly, current is extended, voltage is extended to the backup relay, positive is given to one end of its output contact, and when the backup relay operates, the positive is again extended to the master trip relay. Okay, so also then we have now this whole procedure of the tripping takes place in around 50 milliseconds, 20 milliseconds for the operation of the relay, and about 30 milliseconds for the operation of the breaker. But if it does not breaker but if the breaker gets stuck up, or the 86 relay becomes faulty, or there is any break in this wire, so the breaker will not operate and the fault won't be clear. For that we use an LBB relay. LBB is a backup to the breaker. If the breaker fails to trip due to any reasons, then this it has a timer of 200 milliseconds. For 200 milliseconds, it will wait. If the 200 milliseconds has passed, has finished, then it checks if the fault current still persists, then what it does, it gives extends command to the bus bar. It uses the trip circuit of the bus bar protection, and it trips the entire bus. Okay, so whatever feeders or transformer in or on the bus of that section, that all will trip, and the bus will become dead. Okay, so we'll see the bus bar relay how it operates. Similarly, all the feeders are being fed to the bus bar relay, see current coil, and when the bus bar relay operates. Okay, when there is a differential current, when the incoming is not is equal to outgoing current, and there is a current in the differential coil, differential, so it output contacts operate, and it it trips the 96 relay, which in turn trips the breaker. Okay, so also it has a trip bus. It has a trip bus. It extends command to the trip bus, and when the trip bus is operated, all the feeders slash transformers on that faulty bus section will trip. Also the bus sectionalizer will trip. So this was a short video in which we have tried to explain the protection system overview. Thank you so much.